Hello again, everyone. This is Bob Martin with the Nautilus Dry Docks. Today I am going to walk you through the process of setting up one of our subdrivers from beginning to end. I get a lot of questions. If you do not have RC experience, it's going to be complicated. I really recommend to people, if you do not have RC experience, do your research first. Diving into a model that is going to cost you hundreds, if not thousands of dollars without a solid foundation in RC experience, electronics, and fabrication means you're probably going to struggle through. I'm not saying that it's not possible, but it's going to be a long and somewhat torturous journey. Of course, I'm here to help walk you through it, and we're going to begin with this. And I'm going to set up as an example this Type 7 subdriver. This is a 2-inch diameter subdriver, one of our smaller ones, set up for the 1/72nd scale Revell of Germany Type 7 kit. So let's get started. All right, this is what we have to work with. We have our cylinder complete in its original packaging. I've got a pair of our 850 milliamp hour lithium polymer batteries. We are going to be installing our magnetic mission switch. This is a 10 amp capacity with built-in fuse. We're going to be installing our AD2 automatic pitch control device. And we are going to be installing the battery link and monitor so that we can monitor the battery strength and also the signal strength in a safe manner in the boat. And this is our receiver. In this particular case, we're going to be using Futaba Sky Sport 4-channel radio. For RC submarine control, typically you need 4 channels, one for throttle, one for rudder, one for pitch control, and one for rudder. So, without further delay, let's crack into the cylinder here and see what we've got to work with. So everything is very well packaged. So we have the cylinder itself. We have got the instructions and features. Now this is not a step-by-step walkthrough. It's more like a mission prep handout. So make sure that you read this, become very, very familiar with it. And then there is also instructions for converting this to 2.4 gigahertz operation if you're having a hard time finding 72 or 75 megahertz radio systems. We're going to set these aside. Now, as I said, this is a 2-inch cylinder, and the beauty of buying these smaller ones is the fact that your servos and your electronic speed controller are already set up, installed, and tested for operation. So we don't actually need that for the additional parts. They're already set up. If you get the bigger one, you'll just need to slip your servos in place and wire up your electronic speed controller. Let's crack into the cylinder now. So what we recommend for this is just a slot-headed screwdriver. Just give it a little pop and it comes straight off the end there. Inside is a package of goodies. We've got air hose, this gray tubing. We've got some coaxial cable utilized for extending the receiver antenna for 2.4 gigahertz operation. We're not going to require that in this particular demonstration. We have the float valve for the SAS ballast system. We have our main power cord here that's going to bring power from the battery compartment into the forward electronics compartment. And we've got a bunch of air fittings, magnetic click-on connectors for our linkages, a bow plane connector, a few other goodies in there as well. It also comes with a spare seal for your push rods in case you have some problems with those down the road. So this is our battery compartment. If we zoom out here, we've got three sections to our cylinder. We got our battery compartment, which would sit forward in your boat, central ballast tank, and we have our rear electronics compartment. And if we take a look in the back, we've got dual output shafts for our propulsion, and we've got 3 servos set up, and then we've got air inlets and outlets there as well. So let's pop into the electronics compartment, and again, just a little pry, and then use your thumbs and just wiggle it, and it'll pop right out. So you can see mounted to the inside of this bulkhead is your ballast servo, and that controls your actuating arm that opens and closes your vent valve. Now if you get the gas backup system, the reservoir for that will replace this air reservoir, and the valve for it will slip right into the center of that ballast bulkhead in there, so that when this servo arm pulls in, it depresses the valve and it lets gas escape into the ballast tank and expel the water, causing the boat to rise. So here is the heavy lifting end of our cylinder. You can see we've got 3 servos installed. We have our air pump controller, electronic speed controller, which is pre-wired to your motors. So what we've got here is a whole bunch of leads that we are going to need to address. We have servo connectors, and we have power connectors. The main power for your electronic speed controller and for your air pump can be spliced together. So you would connect the black wires together and the red wires together, and those are going to feed through this central passage, this brass tube, from the electronics compartment all the way through into the battery compartment to connect to power. All right, in order to build up your cylinder, you need to have basic soldering skills. Now, I've got this Weller solder station, but you can get soldering guns for very inexpensively at your local home improvement store. You're going to need to solder connections for your main power to your main power wire, and if you choose to do that, you also need to splice together the servo output or input for your pump controller and for your ballast servo together so that they'll operate on a single channel. Before we get to that though, let's talk about the main power leads. What I'm going to do is just take the power cable, snip it in the center, separate the positive and negative wires, and then I'm going to strip back about 1/4 of an inch off of the ends. And there we go, we got some bare wire there. Now, you can solder this directly to the power leads for your electronics compartment. That just basically means you'll never really be able to fully separate your electronics from your cylinder. I don't really like that a lot. I'm going to use these little mini Dean's connectors. These are available from hobby shops, and this is the miniature version. I really like Dean's connectors. They're high capacity, and they're also very easy to connect together and take apart afterward. So what we're going to do, I'm going to solder the main power to the Dean's connector on one side, and then the pump power and speed controller power to the other side of the Dean's connector. All right, let's talk about tools here. Side cutters, wire cutters. I've got some standard solder. I've got some liquid flux. I have a little mini torch, and of course my soldering gun. Now I've also got this little holder. It makes life a lot easier to hold parts as you're working there. Before we go any further, what I want to do, because I always forget, is slip a little bit of the supplied heat shrink tubing over the wires so that after our connection is made, we can pull those up and heat them up, and it'll cover up our connection. So I've got my female Dean's connector in this little clamp. And as a note, if you're ever wanting to know sort of the standard, when looking at it from the end, you'll see that there is a horizontal pin and a vertical pin. The vertical pin is always positive, and the horizontal one is always negative. So I'm going to put just a drop of liquid flux on there, and also on my wire. I am going to pre-tin the tip of my soldering gun. So now that I've got some solder on the tip of my soldering iron, I'm just going to just lightly touch the tip of the Dean's connector here. And that's going to basically tin the tip, so it's got a little bit of solder on the end of the connector. And I'm going to do the same thing with my wires. So now that that's done, I've got the heat shrink on there. I'm going to simply try and do this so that you can see what I'm doing. Hold the wire up against the tip of the connector and just let the two of them fuse together. Do the same thing on the positive side here. And this looks a lot more awkward than it typically is because I'm trying to do it so that you guys can see what I'm doing. There we go. So we got a nice solid connection to our Dean's connector there. Now what we can do is drop our heat shrink over those exposed ends, and on very low setting with our torch, just lightly go over that heat shrink, locks it down, and that is all solid and ready to go. Okay, there are actually three things that need power in this electronics compartment. You've got your air pump, you have your electronic speed controller, and our battery and link monitor. So what we're going to want to do is make sure that all of our leads are separated and stripped back approximately ½ inch or so, 3/8 of an inch. And that done, we're going to take all of our red leads, which are positive power, and we're going to get those together and we're going to twist them so they make a single output. I am going to tin that, or hit that with a little bit of liquid flux. Tin my soldering iron, just touch it. that's all solidified, and now I'm going to do the same thing with the negative power leads. Twist those together. A little bit of flux. You don't need to use liquid flux. You know, you can get solder that has a rosin core. That'll work well as well. I really like the liquid solder though. All right, that done. Now the only thing left to do is connect that to the male Dean's connector that I've got in the clamp here. So what I am going to do is liquid flux, tin my iron, touch the tabs. Now I'm going to grab a little bit of heat shrink tubing, and you got to make sure that it is of the appropriate size so that it will go over all three of your wires. All right, I'm going to slip over on the positive, slip it over on the negative. Push it back. Make sure you go back, you know, at least an inch or so, because the heat is going to transfer down that wire, and if it gets too hot, it'll heat shrink your heat shrink in the wrong spot, which is not good. All right, that done. Let's see if we can solder that together. So I'm going to tin my tip. Positive again goes to the vertically oriented tab, and the negative to the horizontally oriented tab. If this looks awkward, it's because I'm using my offhands in an attempt to try and make it a little easier for you to see what I'm doing. There we go. Connections are made. Connections are solid. I'm just going to trim off a little bit of excess wire sticking out there. Pull our heat shrink tubing up over the tabs all the way on both sides. There we go. A little bit of heat from our torch. And we're done. Our battery link module now has the ability to monitor the power coming from the battery. Our electronic speed controller has power to power the motors as well as power the receiver, and our air pump has power now as well. Alright, what we're going to need for this next step is a Servo Y harness. These are available at any hobby store, and basically what it does is it takes a single signal and it splits it into two identical ones, and that's exactly what we want to do for our ballast system. So we're going to take the top of the Y here, and we're going to plug in first our air pump, and then for testing here we're going to plug in the servo from our cylinder for the ballast system. The other end gets plugged into your battery link monitor, and just note the wire colors are the same as the input there for the battery link monitor, and they're also labeled white, red, and black, or in this particular case orange, red, and brown, which correspond to the same sort of signals. What we're going to like to do now is take our receiver and we're going to start plugging in all of the various functions and do a test. So the battery link monitor is going to go into channel 4. We're going to take our electronic speed control lead and put it then into channel 3. And then we've got a lead here for our rudder, and that goes in channel 1. And that leaves our pitch controller going on channel 2. And that's going to mean that our stick functions on the transmitter will be lined up with what we want to do in an intuitive way of operating the boat. Now what I'm going to do is I'm going to hook up 7.4 volt power. You can use your battery pack. I've got a desktop power station that I use for testing purposes. I'm going to grab our radio, turn the power on. I'm going to zoom out a little bit here so you can see that. Transmitter power always goes on first, and then receiver power. So nothing has been set up, nothing has been calibrated. We see we got some lights on our battery monitor. It's saying it's got 100% power, which is good because it's a desktop station. On the right stick here, forward and back, is pitch control. You can see the servo operating there for the pitch control, and the other one is rudder. The third servo is going to be spare, so we're simply going to be coiling that up. We've got throttle forward and back, and we've got ballast control. Now our battery and link monitor hasn't been configured yet, and we're going to need to do that right now. So I'm going to power off our radio, our electronics, our receiver. Now in order to enter setup mode, what you want to do is press and hold the button down and then turn power on. Alright, setting up your battery and link monitor has actually a lot of different options. There's fail stages that you can set for stage 1, 2, and 3. You can set your battery type and your cell count. So you've got to do all of that. I'm not going to go into that detail because it's all laid out in detail in this instruction manual, and that'll allow you to set up your battery and link monitor. Alright, I have completed my setup of the battery and link monitor. It's actually pretty straightforward once you go through all of the procedures. I've got it set up for lithium polymer batteries of 7.4 volt size. I have a 3-second delay set on the fail-safe, after which time it will run the blow pump, the air pump, to pump air into the ballast tank for a period of 7 seconds. And that will be enough to get that ballast tank partially empty, get the model positively buoyant, and get it back up to the surface. So I'm actually running, again, a bench power supply, which would actually be low voltage for a fully charged battery. So you can see it's at 50% here right now, so it is showing indication of battery capacity on that unit, so it's pretty slick. Alright, next thing that we need to do is install our automatic pitch controller. Now these units are really popular with the RC Sub crowd because it allows basically autonomous control of the pitch of the submarine, which is important because you can't see it at all times. So it will attempt to keep the boat on a perfectly level keel unless you override it with your transmitter. So what we're going to do, this goes in line with your pitch servo, which in this particular case is right there. So I am going to plug the pitch servo into the pitch controller and the pitch controller into channel 2. There we go. Now let's see what happens when I give the unit some power. So now that the pitch controller has power, you can see that as I tilt it side to side, the servo moves back and forth in its sweep. Now, it is set on maximum sensitivity right now, and I don't like that very much. If you just press and hold this and then let go, it'll go from one red blink to 2 red blinks to 3 red blinks. 1 is maximum sensitivity, 2 is kind of medium sensitivity, and 3 is the least amounts of sensitivity. So I'm going to keep this on 2, and you can see that you know, it doesn't do a lot of jiggling there if I just wiggle this a little bit, which is exactly what we want. Now, I'm going to make a note here that you can install this vertically or horizontally, and it works equally well in both orientations. It just depends on where you've got room in your boat. In this particular case, I am going to be installing it next to the side of the servos, kind of just like this, with a little bit of 2-sided tape and a tie strap, a zap strap. The other thing to note is the direction of servo travel. So as I tilt the unit forward, the servo pushes back. Now you'll just need to note how your linkage is set up in your boat to determine whether you want to orient the unit this way or this way in the model. So let's go about securing this neatly in the electronics tray here, and I'm going to do the same thing with the battery and link monitor as well. Alright, you can see that I have everything bundled up neatly. I will tell you that there's a lot of cable in there, and it'll take a little bit of organizational skills to get everything to fit flush with the back of this equipment tray, because you do not want it to impact the servo for your ballast system there. But that's all done. I've used some zap straps and got everything locked in place. What we're going to do now is we're going to address this receiver antenna. This is the back of the receiver unit. This is the stock antenna that comes off of the back of it. What we want to do is make it so that this antenna stretches out as long as possible in the model, and of course if we jammed it inside the cylinder it would not be able to do so. So the solution to that is to run this receiver antenna along the bottom of the cylinder, and you'll see in the bottom of the bulkhead there is a stud that goes all the way through, and it connects to this wire. Depending on the cylinder you get, it could be blue wire, it could be red wire, but this is your receiver antenna extension, and it goes out the hull and it stays in the wet part of your boat. So what I'm going to do is I'm going to feed this receiver wire through this zap strap here, and what I want to do, make sure I've got, you know, some adequate slack to move this around, you know, if I needed to. And then I'm going to match it up to my stud, and I'm going to cut it off right there. I'm going to strip it back. I'm going to tin that with solder, and then I'm going to pin it underneath this stud. Alright, I have my original receiver antenna with a little bit of slack pinned now to this stud. Now, the entire challenge with this is to make sure that our overall antenna length is precisely the same length as the original antenna length. So to that effect, I am going to match up the cut end with the end of the stud. I'm going to go through that bulkhead, around the corner, underneath, and now I'm simply going to run my hand up this wire, and you're going to see that this extension is about 4 inches too long. So we are going to cut that off, and now what we are left with is an overall antenna length that is exactly the same length as the original antenna length. The last thing that we are going to want to do is put some heat shrink over the tip of this, because what can happen if this boat does go very deep, water pressure can force water down this wire and into your cylinder, which is, as you can imagine, not anything that we want to happen. So we're just going to use a bit of heat shrink on the end of the wire, pinch the tip closed, and this is 100% waterproof once again. Alright, our next step is to take our battery cable that we worked on a little bit earlier with the Dean's connector at one end, nothing on the other end. We're going to feed the unfinished end into the watertight cylinder, into that brass tube that runs down the length of the ballast tank. And it should go fairly easily. If not, you wiggle it and you twist it. You can use some needle nose pliers and you can push it through. Once it gets all the way through, you're going to pull everything out until just about an inch is left on the other side. I'm going to leave it unplugged for right now. Alright, I have inserted the electronics tray in here just so that it doesn't roll around and it's easier to manipulate the cylinder. What we're doing now is we're going to move on to the battery compartment of the watertight cylinder. And first thing I'm actually going to do is address the end cap. And if you take a look at this as it comes, it's got a hole, and that's set up for a physical switch that you would switch on and off. Obviously, the more holes you have in your watertight cylinder, the more prone it's going to be to leaking. So what I'm going to do is I'm going to do away with that hole altogether, and what we're going to utilize is what I had showed you earlier, and that is our magnetic mission switch. Look how tiny that is. It's a magnetic switch that you simply swipe a magnet over the outside of your cylinder and it turns the model on and off. So we need to get rid of this hole because we don't need it anymore. And to do that, I'm just going to take some masking tape. I'm going to go over the outside of the cylinder. I'm going to tape that down really well. Put it down on my workbench there. And what I'm going to use is a little bit of this Arm & Hammer baking soda. And if you followed some of my blogs, or if you go to the blog section of my website, I've showed this tip before. And what you want to do is put just a little skim of that in that hole, and what we're going to add to it is thin cyanoacrylate. And when these two substances combine together, it kicks the cyanoacrylate off instantaneously, creates a lot of heat, might even create a little bit of smoke or steam, but what you're left with at the end is something that basically resembles concrete. It's pretty cool stuff. So I put just maybe 1/8 of an inch of a skim in the bottom of that hole. And now I'm just going to put a few drops in there, and I'm going to let it saturate and soak into it. So I've got a little bit of a base in the bottom of the hole. I'm going to put another little skim over the top, maybe shake it around, level it out a little bit. Add a little bit of more cyanoacrylate. Get a little bit more. And kind of the neat thing about this is you can just skim it over, just like you're troweling concrete. Just like that. A few final drops. I'm just going to wipe the excess off. There we go. So that is solid, cured. You can sand that perfectly flush if you want to. And now on the back, if I did a proper job of this, looks like I've got just a little bit of uncured CA or baking soda in there. I'm just going to add another couple drops of CA. Perfect. This is 100% sealed now. No water will be able to get in and out. Just took a few minutes. You don't have to use cyanoacrylate if you don't have the thin CA or any baking soda. You can use some epoxy or even CA glue if you wanted to, so long as you go in shallow layers. All right, let's get the battery pack addressed. So these are two Vislero 850 milliamp hour lithium polymer batteries. They've got standard RC connections on the back. I'm going to be wiring these up in parallel, meaning that you can stack your capacity while retaining your voltage. So we've got the two battery packs here, and the way I'm going to stack them is you want to have them flipped. You don't want to stack them so that they're both facing the same direction. Not so important for lithium polymer packs as it is for sealed lead acid batteries, but if you ensure that they are opposite each other, if there is any imbalance in terms of weight, it will be offset by the other battery pack so that you don't have to worry about some weird trimming situations later. So got some two-sided 3M adhesive tape. Just going to put that on the lower pack there. We'll peel off the backing. Which can sometimes be a pain. There we go. Make sure that they line up. Press them down, and we have our battery pack. So as I mentioned, the battery packs are going to be wired in parallel, which means we're going to be connecting the red wires together and the black wires connector into a single output. The advantage to these RC connectors on these small battery packs is that we can use another one of these Y splitters that we talked about earlier. You simply connect our battery pack in together like this, and now we have a single output at 7.4 volts because this is a 2-cell battery pack that'll be running at 1700 milliamp hours or 1.7 amps of capacity. Alright, now we need to start talking about the mission switch, which is our electronic on-off switch, our magnetic on-off switch. It's exceptionally tiny, as you can see here. You've got a side that is basically flush and featureless with some text on it, and then you've got the circuit board side. That's the way that you want to look at it. Power in, you're going to use the pads on the top. Power out, you're going to use the pads on the bottom. Positive is on the side facing the circuit boards. If you flip it over, negative is on the side facing the text. So what we want to do here now is split out our power cable that's running to our electronics compartment. Get that prepped for soldering. And the other side, you're going to want to strip off the cabling from the single side there. We do not need any of the white, or in this case orange, leads. Those are for signal in an RC circuit. We just need the red and black. So I'm going to trim that other one right off and strip these back, you know, again about 1/4 of an inch or less. Very important, don't start cutting into these wires with your battery pack connected. You're obviously going to short out and cause a lot of smoke and fire and not good things. So keep that separate for now, and we will move on by soldering yet again. So we'll break out our soldering supplies. Okay, just like previously, I've pre-tinned all of the tips of the wires. Now what I am going to go ahead and do is solder them to the board. So I'm going to start here with the power input side. This is our connector from the battery. Okay, I have already pre-tinned the connections for the wires, and I'm going to do the same thing now with the control board itself. Just put a little bit of the liquid flux on there and just touch the pad just to get a little bit of solder on. I'm going to start with the power in. This is the lead that we had looked at and modified a little earlier. Power in goes on the top when you're looking at the board with the components facing you. And we'll do the same thing with the power out, which goes on the bottom. That done, I'm going to switch it over. Some flux. Pre-tin. And connect. And there we have it. Our magnetic mission switch is now complete. The only thing left to do at this point is to use some of the provided heat shrink, slip it over the entire unit, making sure that your electrical connections are well covered, and just hit that with a little bit of heat. And there we go. Our switch is now in place. We've got power distribution going to the model. All right, I've got my battery pack connected to the magnetic mission switch. Simply tuck our battery pack into the cylinder. There's lots of room. We're going to carefully fold up our cabling, tuck it on top there. And what you want to do is take the mission switch and keep it on the outside of the cylinder. Depending on the strength of your magnet, you'll get about 1/2 inch to 1 inch of room that you'll be able to access the functions of the switch. I'm going to pop my end cap back on, and we've now got our assembled watertight cylinder. I'm going to go back into the electronics compartment now, connect the power, we'll do final setup on the speed controller, and theoretically that aspect is done. Alright, I've connected the main unit to power on the other side. What you're going to want to make sure that you do, like we said, if you've got slack in that power cable, it'll allow you to pull it back and forth as you need it to, depending on whether you're working on the battery compartment or the electronics compartment. Alright, what we are going to do now is calibrate our electronic speed controller. And the process for that is really simple. I'm going to turn on my transmitter. I'm going to get ready to press the setup button on the top of the unit there. I'm going to do this with a screwdriver just because it's hard for me to get my fingers in. Turn the unit on and push that setup button within about a 2-second window. Now what you're going to do is go all the way forward on your transmitter, all the way back, and into center. And what that's going to do is it's going to tell the speed controller how far it can go forward, how far it can go in reverse, and set it up for maximum travel. So if we take a look at the outputs now on the motors, we get all of the capacity of the motors set up now. Alright, one final check of all of the functions of the watertight cylinder. I have it turned on. You can see as I tilt the unit forward and backward, our automatic pitch controller is functioning. Test our pitch control servo. You can see it overrides your automatic pitch controller. And there's our rudder, our speed controller, and our pump, our ballast system. So looking at the side of the unit there for the ballast control, you can see the way that this works. When I vent the tank, this valve opens up at the top, all the air escapes. When I go the other way, the pump kicks in and begins to draw air. Alright, just a couple of things left and this cylinder will be completely set up and ready to go. One thing that you're going to want to do is ensure that every time you make up your cylinder, the end caps are oriented properly in relation to the cylinder. So what you want to do is get it set up so that your central servo output here is lined up with your vent valve and all of the other plumbing. So right down the center line of the cylinder, and then you're just going to want to make a mark that goes from the watertight end cap to the cylinder, just like that, so that you can always match up those lines and everything will always match up the same way every time you put it together. And the last thing that we need to do is hook up all the plumbing for your air lines. Now, taking a look at your air pump, which is right on the top of your cylinder there, you can see we've got two nipples that come off of it. One is along the center line and one is off to the side. The nipple that comes off to the side is going to be your intake, and the one that comes off the center line is your output. And what I've actually gone ahead and done is marked the end of my cap with O and I for out and in. What you want to do now is take the supplied rubber hose, these air hoses, and slip one over each of these pieces of brass tubing that come off of the end. So your input side is actually going to get connected to the right hand piece of brass tubing in the back here. It's the one that has the line that goes all the way through. And you can cut these to length to make sure that everything is nice and tight, but I'm just showing you the routing right now. Now your output is going to go from your end cap to the left hand piece of brass tubing. And if you take a look at the way that that is set up, on the inside of the ballast tank, you'll see that there is a hole that runs into the ballast chamber, so that's where the air is going to get blown into. Now the last thing that we do here is connect our other side of our intake tube to that side, and we've got a little valve assembly here. This is a really slick unit. You can see how it works. You just slip this piece of styrofoam on there. That's the float part of the float valve. And the way that this works is when the model is surfaced, this valve is open. So it's drawing air from the surface. When the model submerges, this float is forced upwards, closes the valve, and underneath the water, when you engage your ballast blow cycle, the system tries to draw air from the surface, but it can't. And so what ends up happening is it needs to draw it from the battery compartment of your cylinder and from this little reservoir here. And so you're going to decrease the air pressure in both your electronics compartment and your ballast compartment, blowing air into the ballast tank, causing the model to become positively buoyant, and up to the surface you go. As soon as the model breaches the surface, the valve opens, air pressure equalizes throughout the cylinder, and it draws air from the surface to finish blowing your ballast tank. So the last thing that you need to do is simply connect your valve assembly with the supplied rubber hose, and you are now done. This is the completed watertight assembly for your boat. You're going to want to tidy up your tubing. Like I said, cut it to length. You can put some guides in on the top of the cylinder to hold your tubing in place. But that's it. That's how it all works. Now everything is functional. I'll show you one time with the radio on and the cylinder working how this ballast system works. Alright, so our cylinder is powered on. You can see our battery and link monitor is indicating that we have about a 75% charge on our batteries. What I'm going to do now is simulate a dive, and the way I'm going to do that, I'm going to engage the vent valve. So the snorkel valve is open because we're surfaced at this point. Close or open up the vent valve on the top. The model submerges. The valve closes on the top. The model's underneath the water. You could be cruising around at periscope depth or deeper. Now what you want to do is engage the ballast system, and I want you to listen for the pump here and the change in output of the pump as it struggles against the air pressure. So it's drawing air from the electronics compartment in the battery. The model is surfacing, model surfaces, and it draws air. So that's it. It's a very, I shouldn't say simple system, but it's not actually overcomplicated when you get to thinking about how it's all plumbed together. The last thing that you want to do is test the functionality of your battery link monitor failsafe, and to do that you simply turn your radio off, and theoretically within about 3 or 4 seconds that air pump should kick in automatically. Let's give it a try. I'm going to turn my radio off. There we go. Pump is now running. It should run for about 7 seconds and then turn itself off. Perfect. Worked exactly as designed to do. It drew air from our electronics compartment, blew it into the ballast. This model should be surfacing all on its own back up to the surface for retrieval or for signal to reach it once again. Well, there you go, everyone. Hopefully this information was useful to you. Setting up the SubDriver unit, available through the nautilusdrydocs.com. If you have any questions, comments, or concerns, by all means, email me at any time. It's bob@rc-sub.com. At the end of this video, I'm going to be putting in a little bit of a schematic that'll show you the routing for all of the power and leads for this. So hopefully that'll be another resource that will be useful for you. Thanks for joining me. If you like what you see, please subscribe to my YouTube channel. Be sure to visit my website at www.nautilusdrydocs.com. Thanks again, everyone. Catch you next time.